Hello class, in this lesson we're going to be learning how to solve equations, trigonometry equations. The primary goal whenever we solve a trigonometry equation is to try to isolate a single function on one side of the equation. Get something like this: sine x is equal to 1/2 or something like that. And we could figure this out once we get it down to this point. So it's a bunch of manipulation that we have to do. We use a variety of ways, combining like terms. For example, when we have 5x plus 3 plus 2x equals x, we can combine like terms to solve that. We could take the square root of both sides. So suppose we have something like 9x squared minus 1 equals 0. We would use square rooting techniques to solve this equation. Factoring. Say we have 3x squared plus x is equal to 1. We see this common term of x here that we could factor out to help solve this equation. Or sorry, equals, let's say it were equal to 0, say. Or maybe you have 3x squared plus 4x plus 1 equals 0. Again, we could factor out something here too. It might not be as easy to factor as this, where you could just factor out the x term, but you can create some sort of this times that equals 0 for this problem as well. For trigonometry equations, we can use identities that we've learned as a way of turning sines into cosines and tangents into sines and cosines and whatnot. And lastly, we could actually use a technique where we end up squaring both sides, and this is kind of unique. Whenever we square both sides, we always have to watch out for extraneous solutions. We did see something like this when we solved something like x plus 1, square root of x plus 1 is equal to, say, 3x. We had to concern ourselves with the possibility of extraneous solutions. Okay, combining like terms, this is a pretty straightforward example here. Both of these terms have sine x, so let's bring them all to one side, and then bring this root 2 to the other side. So we combine them, divide by 2, and at this point, we're going to think about our unit circle, and we think about the two different angles here, coming around here. That gives us a sine value of negative root 2 over 2. And this would give us two general solutions, 5 pi over 4 for this angle here, and then 7 pi over 4 for this angle here, and then we get repeated solutions every 2 pi. We could take the square root as a method, in this case tangent squared. So let's bring all the numbers to the other side. We're going to add 1 to both sides and divide by 3. At this point we're going to take the square root, but don't forget the plus or minus. So in this case, if we were to draw out some cases here, we have this case where pi over 6, we have the tangent of 1 over root 3. But we also have this case over on this side as well. So if we have one case over here, for the tangent we have this same case. So both of these angles here would return a tangent of the positive 1 over root 3. And then these two angles here would return a negative 1 over root 3. So the general solution we have for this would be two solutions, pi over 6 plus pi n, as well as 5 pi over 6 plus pi n. In this case, pi over 6 plus pi n is these two angles in yellow here. This angle going this way, pi over 6, and then we have this one over here, which is 7 pi over 6, but you can see that it's just taking this angle here, pi over 6, and adding pi to it. Then we add pi to it again, add pi to it again, and so on. This other one over here, this is 5 pi over 6 right here. And again, we're adding pi, adding pi, adding pi as we loop around. Okay, this equation here. First off, it might be extremely tempting to cancel out the cotangents, but that would not be something we want to do. So instead, let's subtract. Subtract 2 cotangent from both sides. And in this case, now, instead of dividing by cotangent x, let's actually factor it out. So I factored out the cotangent x, and I'm left with cosine squared x minus 2 here. And then with our, the key property is our a times b equals 0 property, where either, if we have two terms that multiply to 0, either a is 0 or b is 0. Those are possible solutions. So in this case, this is our a, and in this case, this is our b, and so we could set both of these to 0. Cotangent of x is 0 when the cosine is 0, so it's at these two angles. Now this one's an interesting one. There is no solution for this case. There is never a case when the cosine is greater or less than square root of 2. The cosine just never has this big of a value. So in the case here, there's actually no solution for this. So we have a general solution of pi over 2 plus pi n to handle both this case here. This is pi over 2. Then we add pi to it to get 3 pi over 2. And then we can add pi to it to get, the next value, say 5 pi over 2. So this is our general solution for both of these angles. So the warning here, the key takeaway is don't divide away a value. Factor it instead. Bring it all to one side and then factor it. You don't want to lose the solution. Actually, you can see here that if we had divided away the cotangent, just made it disappear, we would have lost this entire solution. We would have kept this side of things, but it didn't have any solution. So we would have thought this had no solution when in actuality it had these solutions right here. Okay, quadratic type, but we have a sine squared, we have a cosine squared. We want to turn everything into one or the other. In this case, it's most convenient to use the Pythagorean identity. Recall here that sine squared x plus cosine squared x is equal to 1. We can use this identity to replace out this here. So 1 minus cosine squared x is the same thing. We're going to distribute the 2 across here. And then I'm going to rewrite it kind of from highest degree to lowest degree terms. So I have this. Now I'm going to try to factor this. In some ways, what I'm doing is I'm pretending like this is just x. 2 times x squared minus 3x plus 1. So I have 2x and this here as well. So I need two things that multiply to 2 cosine squared x, which these do. Two numbers here and here, which multiply to 1. So that's basically -1 and -1, so that I can get a value inside here of -3 cosine x. So now I have two cases, when my cosine is equal to 1/2, or when my cosine of the angle is equal to 1. So I kind of sketch out these cases here. I'm looking again at my x values, 1/2 and 1. So I have solutions, and in this case I decided just to change it up. Instead of general solutions, I'm looking for solutions strictly between 0 and anything less than 2 pi. So these are my 3 different answers that I could have in this case. Here's an interesting case now where I would like to turn my cosine into sine or my sine into cosine, but I can't do that unless I had some sort of, sine squared or cosine squared. So what I'm going to do is I'm going to actually square both sides of the equation. But I have to remember, whenever I do this, I got to check for extraneous solutions. So let's square both sides, and I'm going to expand it out. So I get sine squared on this side, and cosine squared x plus 2 cosine x plus 1. I'm going to do my Pythagorean identity substitution here. You can see that in yellow. Now I'm going to bring everything to one side, so I get a 0 on this side, and now I'm going to attempt to factor out here. I'm not going to cancel or divide away the cosine x that's common. I'm going to factor it out. Okay, so now I have my 2 times a times b, and I'll set either a or b to 0. So in this case, I have some solutions here and some solutions here, but I need to make sure I check my answers. Oh, let's go back. Let's think about this now. Because remember, when we square it, we always have to be careful. So let's consider pi over 2 and 3 pi over 2. That's this diagram right here. 0 is my cosine, 1 is my sine. So let's consider pi over 2 first. So cosine x, which is 0, plus 1, so that's 1, is equal to sine x, which is 1, squared. Okay, so that one seems to check out. Next one, let's look at 3 pi over 2, which is this angle down here. I have my cosine and my sine. So I have 0 plus 1, that's 1, is equal to sine of x, which is negative 1. 1 is equal to negative 1. Not true. I'm going to cross this one out. Last one, let's consider our case over here. This is the angle pi. So I have my cosine sine again. So I have negative 1 plus 1, or yeah, which is 0, equals to 0. Oh, that looks good as well. I have two answers, pi over 2 and pi. Now here's an example with a calculator problem. If I wanted to solve this, I want to consider when is my sine 4/5, and I will need a calculator for this. The unit circle doesn't have a, I don't have a convenient pi over 3, pi over 4, pi over 6 type of case. So I need a calculator. So, if I were to imagine this just kind of inside of a, unit circle and a graph, I would actually have two angles, two solutions. This, I could imagine this height to be 4 and this hypotenuse to be 5, but I also have another angle here where the hypotenuse is 5 and the height is 4. So these are both two legitimate angles whose sine is 4/5, but the calculator only will give us one answer. This is the answer that the calculator gives us. And we'll divide by 2 to get the value for x. But we still need to figure out the other solution. This solution right here, and actually we're, this plus 2 pi n, let's actually write where this comes from. If I wrote this plus 2 pi n, because it repeats every 360 degrees, when we divide it by 2, the 2 pi turns into pi. So that's where this part comes in. But we still need to figure out this other angle here. What is the measure of this? The calculator told us that the angle of this angle right in here was 0.927. So we need to think about how we get this. Now, this angle right in here, let me actually draw a bigger picture over here. We could actually imagine, say, this angle x, and I'll draw that kind of lightly. Then we have this it's a reflection over here, actually. And I want to figure out what this measure here is equal to. But since we know that we have a reflection going on, we could actually label this piece over here x as well. We know this is a linear, this is 180 degrees all the way across. So that means, let's just kind of erase some other stuff that we don't need anymore. And so then we could figure out that this red piece here is actually pi minus x. So whatever this angle is over here, we find this one by subtracting this angle from pi. So 180 degrees minus y, or minus x here. So in this case, our value of 2x, and where did the 2x come from again? Just remember, it's just from here. So 2x is going to be equal to pi minus 0.927. So then we divide by 2 again, and like I said, we have this general case where 2x is equal to 2.2 radians plus, every 2 pi n. So then we divide that by 2, and these are then our two general answers. Oh, and if we want to find the solution within 2 pi, we start off with these two answers here, but then every pi we have another solution. So I'm going to take this, add pi to it, take this, add pi to it, to get another set of solutions that are still within this range 0 to 2 pi. Okay, I have some final problems for you to try here. I'll show you the answers in 3, 2, 1. In this case here, we had absolute value, so whenever we get rid of the absolute value, we put this plus or minus sign here. So then we get a couple solutions that can be expressed like this. Okay, that's it, class. Have a good day.